Okay, now, Mr. Chingis and his team members will give their presentation on the problems and solutions in Chapter 4 and Chapter 5 algorithms.
Well, hello everyone. My name is Chingis and I'm leader of Team 3. Today I'm presenting with you guy Alexander, and I'm going to start by presenting my individual PBL report. So as we have a limited time, I'm going to present some parts of my PBL report really briefly. So as we can see here, I made a kind of summary of what we learned. So here we see a kind of summary of what have we learned during the discrete math class and definitions. So what I want to say by presenting my individual PBL report is that, okay, let me ask you a question. What does studying together means to you? Before coming to this class, studying together was to me like just studying in the same class, I mean in the same place. But due to the system used in this class, I mean Q&A sections, studying together, we actually studying together in this class. So in order to prove that, I'm going to give you a couple of examples. So, yeah. So, okay, let me take this problem. So, the problem was to implement Egyptian form of fraction as a code, and as you can see here, I provided a Python code.
Make it a little bigger so they can read, and speak slowly so they can understand.
So here's my Python code. The main idea of my code was just to subtract. Firstly, we enter any fraction, and then we subtract. We start subtracting from that fraction 1 divided by 2, and then 1 divided by 3, and 1 divided by 4, until it becomes less than 0. So this algorithm was kind of huge, and so it wasn't so efficient, and Mr. Kim Jong-ju provided another solution which was more efficient than mine. So here we see our new algorithm, and he also provided a C code. Oh no, it's Python code. So what's the idea? Due to his solution, I understood one of the property of algorithm, which is efficiency. So I really appreciated that. Another example. So okay, here we needed to explain whether a provided relation equivalent relation or not. So I solved this problem by only providing a D-graph, which is not really efficient because it's not really understandable for all students. But then Jang Jong-moon provided more detailed solution. So thank you for that. And so as we can see, in this class we are actually studying together because by revising and finalizing our solutions, we can make really a good solution for a particular problem, and we can help each other to understand and grasp material and the concept of the class more quickly. So another problem I liked, it was solved by Mohammed and finalized by me and Kim Sun-yeon. So we needed to trace algorithm, which is provided below, for input T and P. So this algorithm is called text search, and the idea of that algorithm is to identify whether a particular pattern, which is P, exists in T. So we can see a detailed solution provided by Mohammed here. And also I provided a hint, and as we can see, when j becomes more than m, the algorithm terminates, which means that if m equals 3, j should be equal to 4, and I also provided a trace table which is really useful to understand the algorithm, because algorithm looks kind of difficult to understand. So the basic idea of the trace table is to concentrate on key points of the code. So as we can see, I and j are key points of that code, and also the Boolean expression. So as we enter the loop, we can see that only j and this expression are changing. So we start from I equals 1 and we move j equals 1. So we can see that the first digit and the first digit of t and p are equals, and it returns true. And then for j, for the second digit of p and the second digit of t, they are equal, so we get true. But the third digit of p is not equal to the third digit of t, then we get false. Then we increment I by 1, and we start comparing t and p starting from the second digit of t, and we get 3 true, which means that this pattern exists in t. So now I'm going to briefly describe some articles I shared in this class. So now, this article was about how the Mergen's laws are used in a computer. So actually you can read it in a team project of team 1. So as you can notice, I noticed that one of my articles was used by team 1, which I really appreciated. So it shows that we, due to a Q&A section, students actually communicate with each other, and we help each other to study and understand materials quickly. So to summarize, I'm really happy that I chose this class, because this class is really unique, and I really like the system used in this class, because it really changed my mind about studying together, because before entering this class I thought like studying together is studying in the same place, I mean in the same class, but actually in this class we're actually studying together by discussing any problem or providing a better solution for a particular problem. So it helps us to grasp and understand the concept of the class and the concept of any chapter more easily. So now I'm going to start presenting team project. So we see the roles of each student collected by Yugai Alexander, typed by Yugai and Kim Sun-yeon, and also comments by Kim Sun-yeon and me, and involved in problem solving Yugai, Gwon Jae-yeon, and me. So we can see a brief summary of chapter 4 and some useful articles shared in a Q&A section, which will help to understand chapter 4 better. So I already explained this solution. Oh no. So this solution is, the problem was to find the maximum value among these three provided numbers, which is a equals 12, b equals 3, and c equals 0. And we were provided pseudocode. So
Mr. Kim Sun-yeon had the interview today, so he took his exam on Wednesday, and his presentation was recorded, so it will be shared. I will let you know the address, so you can hear the presentation of Kim Sun-yeon.
So I also provided a trace table for this problem, because for some students the code can be difficult to understand. So initially we assume that the large numbers A, which is 12, and then we started comparing each number with the assumed large number. So we started from 3, but it's not larger than 12, so we get false. So the value of large doesn't change, and then we compare with C, but still it is less than 12, so the large doesn't change, and so it returns 12. So, and as we can see, we tried to leave comments in both in Korean and English, so it would be more understandable for everyone in this class. So I hope it helps. Then I already explained this problem. Then a shuffle algorithm. This algorithm is a good example for randomized algorithms, which is based on functions which randomize some integers. So the basic idea of this shuffle algorithm is to swap two random elements in a particular sequence. So there is no like general solution for this problem, because we can get different results each time we run a shuffle algorithm, because it depends on the function rand, which randomizes integer value between two particular numbers, which is 2 and 5 here, for example. If we get 5, we swap 2, the second element, and the fifth. So here comments Korean and English. So finding the maximum value, this is a more general solution for the first problem I explained, finding the maximum value, but the key idea here is to find the maximum value in the sequence, not in the provided numbers. So here we can see we used the loop I in order to compare each element in the sequence, and we use the same logic as we used in the first problem I explained. So here's comments.
You have 2 more minutes.
So let's start explaining chapter 5.
So I'm Alexandra from team 3. So I now explain some problem from chapter 5. So first, this is some K term from chapter 5, like a composite binary,
Slow.
like a composite binary,
Understand.
yes, carry, Euclidean algorithm, etc. Some definitions like divisor, prime, concept, and theorems. So it's an article about binary numbers, so I think it will help you to understand it more. It's our source. It's article about Euclidean algorithm, so it's connection with binary numbers. So in it's chapter 5, problem number 2. In this problem, we must find the prime factorization of 539. So it's some definition about prime numbers and prime factor. It's a code that was uploaded by Mohammed. And solution of this problem. So I think this problem can be easily solved by using a factorial tree. So we start from number 7. It's a prime number, so then we find 77 and divide it by 7 and find the 11. 11 is 2 prime numbers. So answer to this exercise is 7. So answer to this exercise is this. Some comment on English. So in second problem is problem number 9 from chapter 5. So in this problem we must use Euclidean algorithm to find the greatest common divisor. So it's a solution, it's a theorem about Euclidean algorithm, and by using this theorem we can easily find the answer to this problem. Number. Yes, it's our team project. So first, I will talk about the reason why we chose this why did we chose this topic. So, as you know, in mathematics and computer science, a binary number is a number expressed based on two numerical system or binary number system, which use only two symbols, typically 0 and 1. So, as you know, the binary number used in physics or actually in programming. So there are three basis operations with binary numbers like addition, subtraction, and multiplication. However, as time has shown, the most frequently used operation with binary numbers is programming. In programming is addition. The addition of binary number is the initial and most important step in the study of operation with binary numbers. Therefore, in our team projects, we decide using the example of problem solving to show simple and most interesting methods of adding binary numbers. We also decide to show how recurrence relations can facilitate the process of adding binary numbers in programming. Is some source. So first, it's our problems, which was arbitrary numbers, for example, 11 and 27. So we translate these two numbers into binary number systems. As you can see, this was easy, maybe. So first, to solve this problem, we show how would, so you can ask your questions, how would you solve this problem by your hands? So it's some tables that can help you to adding binary numbers. So this first step. So it's the similar number. We begin from the right adding, and 1 and 1. This sum is 10 in binary systems. This we write 0 and carry 1. At this point, the computation is this, and we can easily continue so on to take this answer. So then, this example of previous example of how we can sum this two number in decimal system. Yes, it's easy. And in this computer sum decimal and recovering C and B from the formulas. This. Next.
Thank you, Guy. Now we are going to discuss this problem in how we could solve it in programming. So in chapter 4 we were provided this pseudocode, and then we implement the given pseudocode into Python programming language, and we get this code. So here I left some comments which are the idea of the code. So the sum will be printed in the form of text, which is string, and then we temporarily convert string into the list for the convenience, and then we add binary numbers by starting adding last digits, and we also need to calculate carry. So, and then we return the reverse string. So the idea is to read every digit starting from the last one and ending with the first one. So here I provided more details of that code, so that it will be more understandable for students. But actually,
1 minute left.
the beauty of this project is not to show that it's something difficult. We want, actually what we want to show is how every chapter in this class are really closely related to each other. So we noticed that it looks like we always call the previous element of the sequence. Thus there is a possibility to use recursive function instead of loop. So here I provided a Python code where I use recurrence relations. So here we can see that it always invokes a simpler version of itself, and here I provided link for the code, so we can see an example. Just a simple example which will give us 111. So as we can see, let me note again that The beauty of our in-depth study is not so something really difficult. We wanted to show that every chapter in this class are really closely related to each other, and every chapter matters in that class. Thank you.
Any questions or comments? You should have at least one who make your question or comment on your presentation.